This is from the Turkish Math Olympiad 2018, and this is question number 2, right? Okay, so we have a sequence. We have been given a sequence of integers, right? Defined as, well, the first one, x0 is 1, x1 is 2. And we've been given this formula, right? This recurring formula for the value of xn plus 1, right? That's, so and they're supposed to find the residue of mod 2018 of x 2018, right? So I mean, you can solve this like many ways. You can solve this using like induction and stuff. And you can use your intuition too. At the end of the day, you could just like write down a bunch of terms for this one, and then think of well, what could be the sequence, because to be very honest, it's quite obvious what the sequence will be. But you know what, I'm going to use like completely straightforward methods, like machine generated methods for that matter. Okay, so right, so we've been given the sequence. So first we're going to do the characteristic polynomial of that stuff. So right, it's the characteristic polynomial. Wait, English isn't my first language, so I might just spell this wrong. Characteristic poly. And I'm not going to write everything out, but yeah, I'm just going to write that. So that's going to be t to the n plus 1 is equal to 3 times t to the n minus 2 times t to the n minus 1. Now, every time we do this stuff in recurrence relations, we just divide by t, so you can never say that t is 0. And anyways, you'll see why for t being equal to 0, it's absolutely useless, right? That's not a great solution. Anyways, I mean, just think about it, right? If x was 0 here, would it even matter? Would it even be like a great relation? I mean, it'd be obvious that that's a really shit relation. Anyways, we divide this whole equation by t to the we divide by t to the n minus 1, right? Yeah, so we get t squared is equal to 3 to the t minus 2. Okay, and then we move everything to the left hand side. T squared minus 3t plus 2 is equal to 0, right? Okay, so from here we can quite easily factorize this polynomial. So one of the factors will be, it's quite clear, team, right? Or maybe we'll use a quadratic formula, I guess. Yeah, why not? We were going to use official methods, right? If my marker would work, of course. 3 plus minus square root of, okay, let me just write it down here, right? So for ax square plus bx plus c equals 0, we have that x is equal to minus b plus minus the square root of b squared minus 4ac upon 2a, right? So we're just using that for this equation. Anyways, so b, negative b, the negative of negative 3, that's just 3, plus minus square root of, well, 3 to the second power, that's 9, minus 2 times 4 upon 2 times a, but a is 1. Yeah, notice that's like 1 times t, so it's 2. Okay, so it's going to be 3 plus minus, okay, plus minus the square root of 9 minus 8 upon 2. That's actually equal to 3 plus minus the square root of 1 upon 2. Notice the square root of 1 is just 1. 3 plus minus 1 upon 2. Right, that's RT. Yeah, anyways, so now we solve for t. So that means that t12 right, so t is equal to either, so okay, so 3 plus 1 upon 2, I think we can do this in our heads, that's 2, and then 3 minus 1 upon 2 is 1, right? Okay, so hopefully you see where all that comes from. So those are the solutions to our characteristic polynomial. One could argue that 0 is also one of the solutions, but you know what? No, kill yourself if you're going to argue. I mean, that's like nonsensical, and you'll see soon why it's nonsensical. Anyways, so yeah, now we have the solution of our characteristic polynomial, and now we solve for the recurrence relation. So now what we do is we just say that, okay, so xn is equal to a linear combination of these two. So a times 2 plus b times 1 both raised to the nth power. That's how you do this, right? So let me just paint a picture for you. If you say that p is equal to 0, then you're going to get like plus c times 0 to the n. And notice that that's absolutely nonsensical. It goes to 0. So we are going to make sense. You may as well not say it at all. Anyways, and also I'm just going to point the fact out that this comes from like geometric series and expansions and whatnot, which I don't really completely understand, to be honest. So yeah, that's the thing. So yeah, I'm not going to comment on those. So xn is equal to 2 to the n times a plus b, right? So now how we solve for a and b is using the initial values given. So x naught, right? So for n equal to 0, x naught. So for n equal to 0 to the 0, that's going to be 1. So just a plus b is equal to 1. Yeah, it's given up here. Okay, then x1, that's going to be 2a plus b is equal to well, what's x1 equal to? That's equal to 2. That's 2, right? And now notice that we have two variables and two equations. Now of course, if you have like more solutions for the characteristic polynomial, you get like c and d and all that. So how you solve for those is you get more linear combinations here, right? That's quite obvious. So how you solve for those is like you create more and more equations. So you have like 4 variables here, a, b, c and d. So how you solve for those is you write down x0, x1, x2 and x3. So you're gonna get the solutions from there. Anyways, so yeah, those are the two equations, and I'm just going to write this down immediately because it's quite obvious, but I hope you can see where this comes from. So say subtracting these two equations, right? So 2a minus a is a and b minus b is 0. 2 minus 1 is 1, so a is equal to 1, and that immediately implies, because of equation 1, that b is indeed, okay, if my marker would work. Okay, this is annoying. I wish I could use like emojis and stuff here. b is equal to 0. Yeah. So a is equal to 1 and b is equal to 0. Those are our two solutions. That's quite important, right? So we get the general term of this recurrence relation as, I'm gonna write it up here, right? Because why not? So x n in conclusion is equal to, well, 1 times 2 to the n, that's just 2 to the n plus 0. Oh, interesting. Well, the person I found this from solved it like not really using this method, but more like well, I mean, they just, okay, so like they pretty much wrote down a bunch of terms and noticed some pattern, and that's what math's about, right? It's about patterns. So anyways, we found the general term, so we know what this is, right? We know what x sub 2018 is. That's just 2 to the 2018. So now our goal is to find 2 to the 2018. Okay, modulo 2018. You have to find the residue, right? And the least residue may I add. So now this is more like number theory oriented, which I really like, by the way. Like, number theory is one of my favorite subjects in math. It's so cool. Just love the idea of like being able to convert like gigantic numbers like this into like literally one digit numbers. Yeah, you're gonna see soon why. Anyways, so this is 2 to the 2018, right? Taken modulo 2018. So for exponents, we have the Euler-Totion function. And it goes like this. Phi of, say, n. Okay, so if you have, okay, let me just write down like everything about the Euler-Totion function that I know. Like a to the p. If you have like a to the p modulo 2018, modulo say m, then you're supposed to take like so then you're supposed to take p modulo wow, I love this marker. Excuse me. Okay, so I'm just gonna take the blue marker now. I'm too annoyed. So the blue one. Pardon my inconsistency, but I don't have an option. So then you have to take p modulo phi of m, and that's the Euler-Totion function phi. So phi of m is equal to m times 1 minus 1 upon p1 minus 1 upon p2, and this just goes on to the last prime factor of m. You get the point, right? I'm just gonna write it out here because it's gonna interrupt the rest of the space. You know what? I think we have the characteristic polynomial and stuff done with, so I'm just gonna erase this because I'm gonna need the space. Anyways, so we have phi of m, right? And yeah, and this goes on to 1 minus 1 upon pk. Okay, and let me just point out that, okay, let me just point the fact out that where m is equal to p1 to the alpha, p2 to the beta, all the way to pk, I don't know, omega probably, I don't know. Yeah, like the last Greek number that I know, I think it is, but anyways, it doesn't matter. So the exponents here do not matter. We do not care about them here. So yeah, we're gonna use this trick. It's not a trick, trust me, it's a very well-known fact. Anyway, so we're gonna take the phi of 2018, and then we're gonna take 2018 modulo that phi. So I hope you get where my thought process comes from. This is a very straightforward thought process, by the way. This is like very general practice. So anyway, the phi of 2018. And first of all, I guess we have to factorize 2018, right? So 2018 is equal to, let's see, so it's 2. Then it's going to be 1009. And would you look at that? That's a prime number. So yeah, we're pretty much done, right? 2018 times 1 minus 1 upon 2 times 1 minus 1 upon 1009. And now, okay, so these two, I'm going to take common denominators and stuff. So it's going to be 1 by 2, then 1008 by 1009. And then these two multiply together, cancel out this one. And then what we're left with is 1008. Okay, great. So that's phi of 2018, right? So we have to take 2018. We have to think about the fact that it's 2018 modulo 1008. Well, notice that 2016 is 0 modulo 1008, so this is going to be 2 modulo 1008. And would you look at that? That converts a problem, our initial problem here, to 2 to the 2 is congruent to what? Mod 2018. And would you look at that? We know exactly what 2 squared is. If you don't, then I'd suggest going to school or something. Embrace education. Anyways, it's gonna be 4. And that's all there is to this problem. I mean, you could have solved this like many ways. You could solve this with your intuition, not using brute force methods and stuff. But yeah, I don't know. This is like a general method. You can make a computer do this stuff, and that's interesting, right? You can make a computer do all of this. That's so cool to me. I don't know. Anyways, yeah, hope you like this one. And yeah, oh yeah, it's 4, right? Let's think of something. Okay, so a pseudo prime, which is of the form 4k plus 1. Yeah, where k is equal to 17. That makes 4. I don't know. Seems very nice to me. I think you can check. Yeah, that's nice. Okay, subscribe.